In computing, memory refers to a device that is used to store information for immediate use in a computer or related computer hardware device. It typically refers to semiconductor memory, specifically metal oxide semiconductor (MOS) memory, where data is stored within MOS memory cells on a silicon integrated circuit chip. The term memory is often synonymous with the term primary storage. Computer memory operates at a high speed, for example, random access memory (RAM), as a distinction from storage that provides slow-to-access information but offers higher capacities. If needed, the contents of the computer memory can be transferred to secondary storage. A very common way of doing this is through a memory management technique called virtual memory. An archaic synonym for memory is store. The term memory, meaning primary storage or main memory, is often associated with addressable semiconductor memory, i.e. integrated circuits consisting of silicon-based MOS transistors, used for example as primary storage but also other purposes in computers and other digital electronic devices. There are two main kinds of semiconductor memory, volatile and non-volatile. Examples of non-volatile memory are flash memory, used as secondary memory, and ROM, PROM, EPROM, and EPROM memory, used for storing firmware such as BIOS. Examples of volatile memory are primary storage, which is typically dynamic random access memory (DRAM), and fast CPU cache memory, which is typically static random access memory (SRAM) that is fast but energy-consuming, offering lower memory areal density than DRAM. Most semiconductor memory is organized into memory cells or bistable flip-flops, each storing one bit, 0 or 1. Flash memory organization includes both 1 bit per memory cell and multiple bits per cell, called MLC, multiple level cell. The memory cells are grouped into words of fixed word length, for example, 1, 2, 4, 8, 16, 32, 64, or 128-bit. Each word can be accessed by a binary address of n bit, making it possible to store 2 raised by n words in the memory. This implies that processor registers normally are not considered as a memory since they only store 1 word and do not include an addressing mechanism. Typical secondary storage devices are hard disk drives and solid-state drives. Volatile memory is computer memory that requires power to maintain the stored information. Most modern semiconductor volatile memory is either static RAM (SRAM) or dynamic RAM (DRAM). SRAM retains its contents as long as the power is connected and is simpler for interfacing, but uses 6 transistors per bit. Dynamic RAM is more complicated for interfacing and control, needing regular refresh cycles to prevent losing its contents, but uses only 1 transistor and 1 capacitor per bit, allowing it to reach much higher densities and much cheaper per bit costs. SRAM is not worthwhile for desktop system memory, where DRAM dominates but is used for their cache memories. SRAM is commonplace in small embedded systems, which might only need tens of kilobytes or less. Forthcoming volatile memory technologies that aim at replacing or competing with SRAM and DRAM include ZRAM and ARAM. Non-volatile memory is computer memory that can retain the stored information even when not powered. Examples of non-volatile memory include read-only memory, flash memory, most types of magnetic computer storage devices, e.g. hard disk drives, floppy disks, and magnetic tape, optical disks, and early computer storage methods such as paper tape and punched cards. The third category of memory is semi-volatile. The term is used to describe a memory which has some limited non-volatile duration after power is removed, but then data is ultimately lost. A typical goal when using a semi-volatile memory is to provide high performance, durability, etc. associated with volatile memories, while providing some benefits of a true non-volatile memory. Please subscribe, like video, share, comment and click bell icon for upcoming videos.